Jai Hind students. So after finishing the topic of grouping of resistances in series and parallel, we need to attempt some conceptual questions and some questions based on graphical study, right? So let's start with the first question. We'll be discussing some very interesting questions. So let's start with the first question. We are aware of the factors on which the resistance of a conductor depends. Now, if you are asked to plot a graph showing the variation of resistance with the length of the conductor, provided its cross-sectional area remains constant, then what will be the nature of the graph, right? So, graph between resistance and length of a conductor when cross-sectional area is constant. When cross-sectional area is constant, right? So we need to discuss the variation of resistance with the length of the conductor if assume the cross-sectional area to remain constant. First and foremost, you need to be aware of this particular formula. We know that resistance is rho L by A, isn't it? It depends upon the nature of material of the conductor. It depends upon the dimensions of the conductor, that is length as well as cross-sectional area, and it also depends upon the temperature. The resistance of a conductor increases with the increase in the temperature, and the resistance of a conductor decreases with the decrease in the temperature, right? So these are the factors on which the resistance of a conductor depends. It has already been done in the previous lecture, right? So rho, you are aware, it depends only upon the nature of material of the conductor. So it's a constant quantity, and in the question A is given to be constant. Since rho and A are constant, therefore R is directly proportional to L. That is, both these are linearly dependent. With the increase in the length, the resistance will also increase, provided cross-section area is constant. So the graph would be, this is suppose R, and this represents the length of the conductor. It should be a straight line, right? This shows the linear dependency between these two. In case the cross-sectional area remains constant, then if the length of the conductor is made twice, the resistance will also become 2 times. If the length of the conductor is made 4 times, the resistance will also become quadrupled, that is, it will also become 4 times, provided the cross-section area remains constant. Right, students? Okay. Let's attempt the second question. Let us consider the length of the conductor to remain constant. Somehow, the length of a given conductor remains constant and its cross-sectional area is changed. Right? Its cross-sectional area is changed somehow. So, we are dealing with the case which is vice versa of the first question. So, in that scenario, we are supposed to plot a graph showing the variation between resistance and the diameter of the wire. So, in the next part, we will discuss graph between resistance and diameter when the length of the wire is constant, when L is constant. So, again we will make use of this formula. This is the basic formula. R is equal to rho L by A. Now look, this is the wire. Wire is normally in a cylindrical form, like this. This is the cross-section area A, and suppose D is the diameter and R is the radius. So what will be the cross-section area? It's a circular area, so it is pi r square. Now radius, we are aware it's half of the diameter, so it will give us pi d square by 4. Isn't it? D is the diameter. So therefore, substituting this value over here, we get rho L by, in place of A, we will write pi d square, and over here 4. Now look, this is the key point. Length is constant. So length is constant, 4 is constant, rho, it's the resistivity of specific resistance. For a given material, it will remain constant. Pi is constant. Therefore, resistance is inversely proportional to the square of the diameter. Right? So we need to plot a graph between these two. So it will be a curve. So the graph would be like this. This is resistance, and student, this is suppose the diameter. So it will be like this. It will touch at infinity on both the axes. So this shows the variation of resistance with the diameter of a given wire in case the length of the wire is assumed to be constant. Right? This graph is valid only when A is constant, that is cross-sectional area is constant, and this graph between R and A is valid only when L is constant. Clear, students? Okay, let's attempt some other interesting questions. Right? Let us consider graph between V and I is plotted for a conductor at two different temperatures, right? At two different temperatures, T1 and T2. And the graph obtained is as shown below. So this is the third question which we are trying to attempt. This is graph between V and I. And at two different temperatures, the graph is plotted. Right? Again, I repeat my question. This is an interesting question, students. Please concentrate. What I've said is, graph between potential difference and the current is plotted for a conductor at two different temperatures, T1 and T2. Right? We are supposed to find out the relationship in T1 and T2. Means, I'll give you some options. Option A is suppose T1 is equal to T2. B is T1 is greater than T2. C is T2 is greater than T1. And D is none of the above. Right? So we need to get the relationship in T1 and T2. It's very, very good question. Right? So here, first and foremost, the basic knowledge which you need to have, which you need to possess so as to solve this particular question or such questions is, first, slope of this graph. Slope of VI graph. It will give us resistance. Slope is y2 minus y1 divided by x2 minus x1. Y-axis represents potential difference, x-axis represents current. So y-axis divided by x, R is equal to V by I. So that will give us resistance. Clear, students? So this is suppose theta 2 and let us consider this to be theta 1. It is pretty clear. Theta 1 is greater than theta 2. Therefore, tan theta 1 is greater than tan theta 2. And slope, as you are aware, it's equal to tan theta, isn't it? So what I mean to say is that slope of first is greater than slope of second. So this is the slope. This is slope. It is more slanting and it is quite flat, isn't it? This is more slanting. So this graph, first one, will have more slope as compared to this one. Mathematically, slope is tangent of theta. So theta 1 being greater, tan theta 1 will be greater than tan theta 2, isn't it? So slope of first graph is greater than slope of second graph. And since slope gives us resistance, therefore R1 would be greater than R2. I hope it's pretty clear. So in this case, at temperature T1, the conductor will have more resistance, while the same conductor at temperature T2 will have lesser value of resistance. Clear, student? Next important point. Students, resistance of a conductor increases with the increase in the temperature, or resistance of a conductor decreases with the decrease in the temperature. If the temperature increases, then resistance will also increase. If the temperature decreases, resistance will also decrease. So, R1 being greater than R2, therefore T1 must be greater than T2, because at higher temperature the resistance will be higher. So since with the increase in the temperature resistance increases and with the decrease in the temperature resistance decreases, therefore R1 greater than R2 implies that T1 is greater than T2. Clear, students? So this was a question which is based on these two facts. First is slope of VI graph will give us resistance. Second is resistance of a conductor increases with the increase in the temperature of the conductor. So in this case, T1 would be greater than T2. Option D must be the correct one. Now students, before proceeding with the next question, here I must mention you, in the same question, if the graph between V and I is given by this, note down the difference between these two. Here the potential difference is plotted along y-axis and current is plotted along x-axis, and here the physical quantities have been interchanged. So now, suppose this is T1 and T2. In this case, what would be the valid relationship between T1 and T2? Now what you need to do is, concentrate students. I told you, slope of VI graph will give us resistance, but it will give us resistance only when V is plotted along y-axis and the current is plotted along x-axis. Here I is plotted along y-axis, so slope will give us current divided by voltage, and current divided by voltage is reciprocal of resistance. Isn't it students? So here slope will give us reciprocal of resistance. So while attempting to conclude a graphical situation or graphical interpretation, then always keep in mind the x-axis and y-axis, the physical quantities which are represented along the x direction and the y direction. That's very, very important, right? So here VI graph, the slope gives resistance. In this VI graph, the slope gives reciprocal of the resistance, right? It is because I by V is equal to 1 by R as per Ohm's law. You can arrange it and we'll get V equals to IR. And rest everything will be same as was done in the previous case. Slope of first one would be greater than slope of second one, no doubt regarding this. Therefore 1 by R1 would be greater than 1 by R2, or in this case R2 would be greater than R1, isn't it? And as we are aware, resistance increases with the increase of the temperature. So from this we can safely conclude that T2 is greater than T1. So for this situation, when I is plotted along y-axis, voltage is plotted along x-axis, the correct option would be this one, T2 is greater than T1. Again this one, T2 is greater than T1. Understood students? So, this was a very, very important result, right? Let's discuss some other questions as well. Fourth one. Suppose students, two resistors R1 and R2 are given. Two resistors R1 and R2 are given. They are first connected in series and then they are connected in parallel, right? You are supposed, and then V and I graph is plotted in both the cases. So this is V and this is I. So two resistors are given. This is R1 and the second one is suppose R2. They are first joined in series, right? And then the graph between V and I is plotted. Suppose the graph obtained is like this. Any graph. And then the same two resistors are connected in parallel. And then again VI graph is plotted. So suppose this is A and this is B. In both the cases, it would be a straight line inclined towards the horizontal axis, isn't it? VI, both are linearly dependent to each other. Therefore, the graph would be a straight line. We have discussed it, right? Since Ohm's law is assumed to be obeyed strictly. Now, my question is, which of these two, A and B, represents series combination and parallel combination? I repeat my question. It's again a very interesting one. Two resistors R1 and R2 are given. They are connected in series and then they are connected in parallel. In both cases, the VI graph is plotted when they are connected in series and when they are connected in parallel. Which of these two, A and B, will represent series and parallel grouping, right? So, key point is R series is always greater than R parallel. This we are already aware of. What is the formula for the equivalent resistance when the resistors are connected in series? That is, R is equal to R1 plus R2 plus R3. So there the equivalent resistance increases. While in parallel we use that reciprocal wala formula. That is, 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So in the parallel grouping the resistance decreases. So R series is always greater than R parallel. So this is the first basic knowledge you should have. Second is, in this case, the slope will give us resistance. Slope is V by I, which will give us resistance, isn't it? Now, slope of A is greater than slope of B. No doubt regarding this. It's pretty clear from the diagram. Slope of A is more than that of slope of B. B is quite flat as compared to A. So, slope gives resistance. So, RA would be greater than RB. So, in case A, the resistance is more. In case B, the resistance is less. So, A must represent series grouping of these two resistors and B must represent the parallel grouping of these two resistors. Right, students? And again, let's consider the vice versa case. Let's interchange these two physical quantities. So, what will be the answer if I and B are interchanged? Suppose current is represented by y-axis and potential difference is represented along x-axis. This is A and this is B. Here, slope will give us I by V, which is equal to reciprocal of resistance. So, slope of A is greater than slope of B. No doubt regarding this, right? Now, slope in this case will give us reciprocal of the resistance. Therefore, it is 1 by RA is greater than 1 by RB, or RB is greater than RA. So, equivalent resistance in case B is found to be greater than in case A, and in series the resultant resistance is always higher, right? So, in this case B will represent the series grouping of R1 and R2, while A will represent the parallel grouping of R1 and R2. So, students, I hope you have understood these questions. So, don't jump into conclusion. First, consider which physical quantity is represented along x direction or along y direction, and consider the slope of that particular graph. That will help you in solving such questions, right? So, after discussing this very important graphical interpretation, let's discuss some other questions as well. Okay, let us consider the case where the resistors are given, a resistor is given, and its length is L, suppose, cross section area is A, and its resistance is given to be, suppose, 10 ohm, and it is cut into 5 equal parts. It is cut into 5 equal parts. 1, 2, 3, 4 and 5 equal parts. So what will be the resistance and resistivity of each part? So let's consider each part. So it will be like this. If it is cut into 5 equal parts, then the length of each part will be L by 5. So in case of cutting the wire into equal parts, the cross-section area will remain constant, isn't it? So here A is constant. And students, I have told you, when A is constant, then resistance is directly proportional to the length of the conductor, isn't it? So, if the length becomes 1 by 5th, therefore resistance, new resistance would be equal to 1 by 5 times the original resistance. Original resistance was 10. So, it will be 2 ohm. Got it, students? So R is directly proportional to length only when cross-section area remains constant. Then only R is directly proportional to L. So here the wire is being cut so that cross-section area of each of the part remains constant. So in this case resistance will be directly proportional to the length of that piece. So length of each part will be 1 by 5th. Therefore resistance of each part will become 1 by 5th of the original value. So it will become 2 ohm. Right? What about resistivity? Now suppose the resistivity of the original wire is rho. Now this part, it is made up of the same material obviously. So the resistivity will remain constant. It won't depend upon the dimensions. Because when they change in the dimension, the resistance will also change, so that the ratio always remains constant. So rho, which is the resistivity of a given material, it only and only depends upon the nature of material of the conductor and the physical conditions like temperature. With the increase in the temperature, the resistivity or resistance also increases, right? So resistivity is independent of the dimensions of the conductor. Whether you cut it into 10 equal parts or 100 equal parts, each part will possess the same resistivity because it is made of the same material. Even if it is stressed or it is melted and recast into some other shape, then also the resistivity of the material will remain same or constant. Understood, students? Here I must give you another example of stretching of a wire, right? In case of cutting, the cross-section area remains constant. What happens in the same case if the wire is stretched to twice its original length, right? So let's discuss those questions. So what to do is, suppose a wire of resistance is given. A wire of resistance R is given. Its length is suppose L naught, original length. Its cross-section area is A naught, the original area. Its resistance is R, resistivity is rho, right? Let us consider this wire to be stressed n times. N may be 2, n may be 3, n may be 4. Suppose its length is stressed to n times. So what happens is, this will be the case. Now obviously on stretching the wire, the length will increase, the cross-section area will keep on decreasing. So suppose the new area is A and the new length is L. New resistance is R. Here the original resistance is considered to be R naught. It is of the same material, so resistivity will remain constant. And it's increased by n times. So it is n times the original length. So what will be the new resistance? So this is a very, very important concept. So let's try to get a formula which we can use directly while solving numericals. Right, students? So let's solve it. Understood my question now? A wire is given. This is the original resistance, original length, original area. Right? It is stressed to n times its original length. Now while stretching, I am not cutting it, I am stretching it. On stretching, what happens? The volume of both the cases will remain constant. But with the increase in the length, the cross-section area will decrease. So a length area both will get decreased. Resistivity will remain same. So what will be the new resistance? So let's find out. First and foremost, what you need to do is, what is constant in these two cases? Volume. Volume will remain constant, right? So what about the volume in this case? A naught, N naught. Wire is in the form of a cylinder, and the volume of a cylinder is cross-section area multiplied by height or length. What about the volume in this case? It is AL. This is done. So what about A by A naught? A by A naught, it will be equal to L naught by L, which is equal to L naught by L is 1 by L. Put this as equation number 1. Clear, students? Okay. Second is, what's the resistance? What's the formula for the resistance? It is rho L by A, right? This is the original resistance. What about the new resistance? It will be rho L by A. This is the new resistance. Now, if we divide second from third, what we get is third divided by second. What we get is R by R naught is equal to L by L naught and A naught by A, right? We'll get this. So rho will get cancelled. So let's substitute the value. What is L by L naught? L by L naught is N. What is A naught by A? A by A naught is 1 by N. Therefore, A naught by A would be reciprocal of 1 by N. That is again N. So what do you get? R is equal to N square multiplied by R naught. This is, student, a very, very important formula. which we can make use in MCQs, multiple choice questions, and in various competitive examinations. You can directly make use of this particular formula, right? N is the number of times the wire is pressed or compressed. So, we have derived this particular formula. Now let's make use of this formula in solving such questions. Suppose the original wire has a resistance of 10 ohm. And let us consider this wire is stretched to twice its original length. So N is suppose 2 times. So what will be the new resistance? It won't become twice. In this case, even if the length becomes twice, its resistance will not become twice. Why? Because area is not remaining constant. With the increase in the length, the area will get decreased. So here, resistance would not be directly proportional to length because of the change in its area. Right? So here in this case, this formula is to be used. This formula is to be used only in the case of stretching or compressing, when the area changes with the change in the length. Clear? So here N is 2. So what will be the new resistance? What is the new resistance of this wire? If it is stretched to twice its original length, it will be given by N square R naught. N is 2. So 2 square into original resistance. So it will be 4 into 10. So it will be equal to 40 ohm. Clear, students? So if the original wire is of resistance 10 ohm and it is stretched to twice its original length, then new resistance would become 40 ohm. 2 square, that is 4 times the original length. Again, let's discuss some other portion. Suppose its resistance is 10 ohm, original resistance. It is stretched to thrice its original length. Thrice, 3 times. So what will be its new resistance? Square of 3, that is 9. 9 times the original resistance. That is, it will become 90 ohm. Clear? Let's take still another example. Suppose its original resistance is 10 ohm and its length is quadrupled. It is stretched such that its length becomes 4 times its original length. So what will be the new resistance? In that case, it will become 4 square. That is 16 times the original length. That is, the new resistance will be 160 ohm. Clear, students? And it is also valid in the compressing case as well. Suppose the wire is melted and it is recast into another cylindrical wire having shape like this. Same cylindrical shape, but here length, suppose it gets reduced like this. It is melted and it is recast in this particular shape, right? So here this is the new length. And suppose it again becomes n times the original length. Obviously area will get increased over here. So let's deal with this question. Let us consider this to be wire of resistance 10 ohm. It is melted and recast into another wire having length half of its original length. So here N is equal to half. It is compressed, right? Or it is recast into another cylindrical wire having length half as that of the original length. So N over here is half. So what will be the new resistance? So again the same formula is applicable here. This formula is applicable only when with the increase or decrease in the length, the area also changes. Then this formula can be used, right? In case area remains constant, then simply R is directly proportional to the length of the conductor. So coming back to this question, if it is compressed to half its original length, so what will be the new resistance in this case? So new resistance would be, what's the formula? N square R naught. N square, that is N over here is half into R naught. That is 1 by 4 and original resistance is 10 ohm. So it will give us 2.5 ohm. Clear, students? So while solving multiple choice questions, you can make use of this formula directly. So I hope you have understood this concept, and as I keep saying this frequently, you practice as many numericals as possible. Numericals are an integral part of physics. Without numericals, physics is incomplete. First, try to have a sound basic theoretical knowledge of the concepts and then attempt numericals. And definitely you will succeed and gain in confidence. With that, Let's conclude this session and we'll continue in the next lecture.